This video goes over how to multiply and divide rational expressions, which is useful when you are trying to simplify. Anytime you're multiplying and dividing a rational expression, you should always factor, state the restrictions, divide or reduce by common factors, and finally, actually do the multiplication. So in A, I'm going to simplify here. So the first thing that I'm going to notice is that I can reduce across diagonally by dividing sort of the top and bottom by 2, which is going to leave me with 3/7. My next example, I've got 9/2 divided by 18/7. So I'm going to remember that when I'm dividing fractions, I'm going to invert and multiply. And then I'm going to check and see if I can reduce before I multiply across. Noticing that I've got 9 and 18, I can reduce that to a 1 and a 2. And then I can multiply the tops together and the bottoms together to give me 7/4. Now in example C, we're going to add in some variables. So I'm multiplying. I can't factor because I just have monomials. The next thing that I'm going to do is state restrictions. It doesn't matter what value I use for x. None of the values I choose are going to cause a problem here. So there are no restrictions. Third step is I'm going to divide or reduce by common factors. So if I look at the 4 and the 3, there are no common factors in between those two. But the 5 and the 25, I can divide both of those by 5. And now I can multiply the tops together and multiply the bottoms together, just like I did in A and B, where I only had numbers. So 3x² / 20 would be my final simplified answer. Let's do an example of division. So first thing that I want to do is check and see if I can factor. I can't, which is fine. So then I'm going to move on to dividing or reducing by common factors and stating my restrictions. So the first thing that I'm going to notice is right away I've got a y on the denominator. So that means that y can't equal 0. So then I'm going to go ahead, invert and multiply. And then I'm going to check and see if I can state any more restrictions and then divide or reduce. At this step, I notice that I've got an x on the bottom, so that means x also can't equal 0. And now I've listed all my restrictions, so I can divide or reduce by common factors. So looking at the 5 and the 10, I can reduce that. And looking at the x² and the x³, I can reduce that as well using my power rules. So I've got minus 3y on the top over x on the bottom. Okay. Looking at our next example here, I've got a multiplication. I'm going to check and see if I can factor. I can't because I only have monomials. Then I'm going to state my restrictions. So let's get started. Oh, let's go back here for a minute. I think I had a 2 here when I reduced. So this should be minus 6y over x for example D. Okay. Now moving on to E, we can't factor. We're going to state restrictions right away. I notice that I've got an x and a y on the bottom. So that means that x can't equal 0 and y can't equal 0. And then I'm going to go ahead and divide or reduce by common factors. So looking at my numbers first, I can reduce the 16 and the 2 to 8 on the top. And I can reduce the 9 and the 3 to 3 on the top. Now I'm going to look across at my y's. I'm left with y² on the bottom right. And looking diagonally at my x's, I'm left with x² on the top right. So now I can go ahead and multiply across the tops and multiply across on the bottoms. And I'm going to get 24 x squared y all over y squared on the bottom. And then I'm going to notice that I can still cancel out another y. So my final answer is 24 x squared over y, with my restrictions that x can't equal 0 and y can't equal 0. The last example that we're going to do in this section is a little bit more complicated. Now I've got something that has a binomial. It's already in factored form, so I can't reduce it any further. So the next thing that I'm going to do is state my restrictions. So I'm going to look at my denominator in the first fraction, and that's going to tell me that x plus y can't equal 0. So that means that x can't equal negative y, and y can't equal negative x. On my second denominator, I've got x can't equal 0, and those are my 3 restrictions. Now I can go ahead and check and see if I can divide or reduce. I can't in this case, so I can go ahead and multiply the tops together and multiply the bottoms together. There is no need to expand and simplify in this case. This is a simplified enough final answer. Let's take a look at some examples where we can factor. So in example 2, we're still simplifying. And we're going to start off by checking to see if we can factor. So I notice that I can factor my first numerator as a simple trinomial, x plus 2, x plus 3. I can also factor my denominator using common factoring as x times x minus 4. And in my second fraction, I can common factor the top. And then I'm going to leave the bottom alone because I can't factor that at all. Now I'm going to state my restrictions. So checking my first denominator, that tells me that x can't equal 0. X also can't equal 4. And then my denominator in the second fraction tells me that x can't equal negative 2. Now that I've done that step, I'm going to go ahead and check and see if I can reduce. I notice that I've got x plus 2 on the top left and x plus 2 on the bottom right, so I can cancel those out. And then I notice that I've got x minus 4 on the bottom left and x minus 4 on the top right, so I can cancel those out as well. And then I can go ahead and multiply the tops together and multiply the bottoms together, leaving me with x and my restrictions up here. The last one that we're going to do is a division example. So the first thing that I'm going to do is factor. Numerator of my first fraction is as simple as it gets. The denominator is a difference of squares, so x minus y times x plus y. And then in my second fraction here, this one can be a little bit tricky to see, but I'm going to rewrite the numerator as if it didn't have any y's. Doing that for both now makes it look like I'm factoring 2 simple trinomials. And what I can do is factor it as a simple trinomial and just put the y in the second spot. That's going to guarantee me that I have the y squared where I need it to be. So I can factor this as x plus y times x minus 2y. Notice my 2 numbers at the end are 1 and minus 2. Those 2 numbers multiply to minus 2 and add to minus 1. On the denominator, I'm looking for 2 numbers that multiply to 1 and add to 2. That is actually happens to be a perfect square trinomial, so x plus y and x plus y. Now that I've done that step, I'm going to state any restrictions that I have here. And so from my denominator on my first fraction, I've got x can't equal y and x can't equal negative y. Checking on my second one, both brackets would lead me to the restriction of x can't equal negative y, and I've already accounted for that. Because I'm doing division, I need to invert and multiply. So I've got x plus y times x plus y over x plus y times x minus 2y. Now because I've inverted, now I'm going to check and make sure that I don't need to state any more restrictions. So x plus y is my first bracket here. X can't equal negative y. I already have that one. But I also have the restriction that x can't equal 2y. Now that I've done that, I've stated all my restrictions. I can reduce before I multiply across. So I'm going to notice that going from the bottom left to the top right, I've got an x plus y and an x plus y, so I can cancel those out. And then going from the top left to the bottom right, I've got x minus 2y and x minus 2y. And the final thing that I'm going to notice is that I've got x plus y over x plus y. So the only thing that I'm left with is 1 over x minus y. Those are some examples of how to simplify rational expressions by multiplying and dividing. You should be able to simplify them using power rules and by using factoring techniques.